Hello, welcome to my lab presentation. The purpose of this second lab was to get a closer true to nature approximation of the charges of the two tapes so that we could avoid the error that we had in the first lab. We modeled them as distributed yet discrete point charges along a surface rather than simply one single point charge as we did before. We used several fundamental physical concepts in this lab to get the values for charge and field. Among these were Newton's second and third law describing forces and force partner pairs, as well as Coulomb's law relating the electric field of a point charge to its distance and the magnitude of the charge, as well as the principle that electric field times the charge of an observation particle renders us the electric force on that particle from the external field. Additionally, we had to make several assumptions for the sake of simplicity, clarity, and feasibility of experimental process. Among these assumptions are that the charge of the two tapes were equal in magnitude. We assumed this because we produced the charges tapes in the same way each time, so it was a fairly reasonable assumption. Secondly, we assumed that the charges of the tapes were distributed perfectly evenly among the tapes. This might have been a slightly erroneous assumption, but it was necessary for the sake of this experiment. Additionally, air resistance was neglected, and the transit time in which the tape had to overcome the force of gravity. We did not consider the force of friction against the air molecules that it likely did experience in reality. Additionally, each tape was approximated not by one point charge, but in this case by 50 evenly distributed discrete point charges so that it could more accurately reflect the true to nature model of a perfectly distributed continuous point charge, which is in fact not discrete. The results, we computed that the charge of the tape was equal to 2.15 times 10 to the negative 8th coulombs. And again, it was assumed that both tapes had the same charge. This value was well over 2 times the previously computed value, which was given to us by, again, modeling them as a single point charge. And like I said, as compared with the previous model, it was much, much bigger, in fact, a different order of magnitude. And it's pretty safe to assume that this second model was more accurate and more true to nature, as it more closely reflected the truth that we would expect of a distributed continuous charge rather than a single point at the geometric center of the tape. Here is my code. You can see here I've defined my physical constants. This is 1 over 4 pi epsilon naught, which is a known physical constant, as well as the acceleration due to gravity. Defined the mass of the tapes, as well as this charge. Here, this is important. This was simply a after-the-fact computation to make sure that the electric force from the external and the gravitational force on the upper tape were equal. I had to tamper with this value until I found this multiplier here. This value here is the previously assumed charge of the tape. So this was the ultimate result of the experiment there. The distance between the two charges, or the two tapes, sorry. This function creates an electric field. As you can see, this is simply Coulomb's law. This loop here is 2 nested for loops. This first iterates for every discrete point charge. In this case, I defined them to be right here, 50 separate point charges. It iterates through each one of them, so 50 in total. Creates a vector for electric field, initializes it at 0, and then defines that vector to be simply the Coulomb's law given up here. And then we iterate for each point charge we look at, we iterate for the bottom tape point charges, each 50, so we can calculate the superposed vector on each individual discrete differential point charge, so that with these two nested for loops, we can create a valid superposition of the entire system. And that is all of the code. When you run it, you see this beautiful picture of each green vector representing the superposed electric field vectors acted upon by the blue here. This is the bottom tape, the red's the upper tape. The white is simply the electric force vector, and the yellow is equal in magnitude, negative in direction, the gravitational force vector. These results are as we would expect and consistent with our natural model.